Okay. And I'm going to record to the cloud. All right. Welcome everybody to the Morgan State seminars. My name is Sean Bohan. I'm going to turn it over to Tanisha, who's going to give us an introduction, and then I'm going to introduce Hyperledger and our speaker today, Hart Montgomery. So Tanisha, you're up.
All right. Thank you, Sean. My name is Tanisha Brown. I am the Program Communications and Outreach Coordinator for the National FinTech Center. The National FinTech Center is the hub for the HBCU community in the blockchain and FinTech space. We are proud associate members of the Hyperledger Foundation, and we want to give a special thanks to them for co-organizing this seminar and many other seminars. We would love to continue the partnership, and I thank you again for coming.
Outstanding. And my name is Sean Bohan. I'm a community architect at Hyperledger. We've been working with the FinTech Center at Morgan State for a couple of years now, and we're pretty excited about this program. These really aren't hands-on workshops. They're more like lectures and discussions around topics around the FinTech that are involved with the FinTech Center. Hyperledger is part of the Linux Foundation, and we are we host the communities that build and the software projects that are enterprise blockchain. Everything from Hyperledger Fabric and Sawtooth to Indy and Aries and a number of tools as well. Our speaker today is Hart Montgomery, who is the Chief Technology Officer at Hyperledger. He is going to take us through a presentation around decentralization and privacy on the blockchain, just the basics. A couple of times during the presentation, I'm going to post links in the chat in case you want to find the wiki page for this presentation or the wiki page for the seminar series or the Hyperledger Discord, which is where all our conversations happen. And we will also be doing Q&A. If you have a question, please post the question in the chat. I will be going over the questions with Hart when we take breaks or when we get to question time. And I would like to thank everybody and turn it over to Hart. Hart, take it away.
Awesome. Can everybody hear me?
You sound good.
That's probably too kind, but thank you, Sean. All right. So hello, everyone today. Thank you for having me. And today I'm going to be talking about decentralization and privacy on blockchain. And thank you for the introduction, Sean. So Sean already introduced me, so I don't think I need to go, too much into my background. So let's just get started. So, today I'm going to talk about, sort of three core things. I'm going to get into blockchain and decentralization by explaining the Byzantine generals problem. Then I'm going to talk about, sort of decentralization, which is the core of Web3 and blockchain. And then we're going to go into some of the drawbacks of blockchain and decentralization. And really one of the biggest things here is privacy. And so that's how we're going to get into privacy. So let's get started. Let's start by talking about the Byzantine generals problem, which will motivate blockchain and decentralization. So what is the Byzantine generals problem? Well, suppose we have some number of generals, and this could be an arbitrary number, but for now, I'll assume that it's 5, and they need to decide whether to attack a fortress or retreat. If all the generals attack, victory is very likely. If all the generals retreat, losses are minimal. But we'll say if 3 or less generals attack, then it's a catastrophe, right? It's a big problem. So how might the generals decide? Well, if there's no one general in charge, we might think the generals might vote, right? That's sort of the natural and easy way to think about this, right? So the generals could send messengers to each other. So this general could send a messenger to the other general saying, I want to attack. Another general could say, I want to retreat. The third general could say, well, I also want to retreat. The fourth general could say, I want to attack, and the last general could also want to attack, right? And they're sending messages to each other to handle this vote, right? And then finally, right, since they've concluded a vote, there are 3 votes for attacking and 2 votes for retreating. All the generals will decide to attack, and there will likely be a good outcome. So the problem gets interesting, and the problem is sort of formally defined in this way, is what happens if a general is a traitor, right? So what happens if one of these generals is actually not honest? Well, what could they do, right? So if we go back through our voting situation again, we could have one general propose to attack, the second one says to retreat, the third one says to retreat, and then the fourth one says to attack again. So we're sort of tied at two for votes. Well, what can this, corrupted or this traitorous general do, right? Well, what if the general tells two people that he wants to attack and two people that he wants to retreat, right? Now, this sort of complicates the vote, right? Because for these two people on the top, the perspective is, well, the majority voted to attack, we should attack. And for these two generals on the bottom, the view is that the majority voted to retreat, we should retreat, right? And then, if this actually happens, we would have two generals attacking and three retreating, and we'll assume the corrupted general retreats. And this is, of course, a disaster, right, by our problem statement. And so you might ask, well, what can we do about this, right? And really the solution is something that's called a distributed consensus protocol, which is at the heart of both decentralization and blockchain. And the guarantee is that if more than 2/3 of the generals are honest, and I don't really want to formally define what that means, but it means, essentially what you think it does, that all of the honest generals will take the same will take the same action. We obviously can't guarantee what, traitorous generals will do, but, we can assume that honest generals will take the appropriate action. And this is called Byzantine fault tolerant consensus. I don't think there's actually any connection to the Byzantine Empire other than just the problem somehow got named this. And again, this is the backbone of blockchain and Web3. And, someone is definitely going to ask, how can we fix this problem? And the simple answer is communication between the generals. So what the generals will have to do is they will have to discuss each other's responses with each other, right? So these other generals will have to say, basically, did this guy tell you to attack? He told me to attack, basically. So there will have to be more communication. And you can prove mathematically that you actually need this extra communication. And I don't want to get too much into the details on this because it does get very technical in a hurry. But this is the basic idea. And to get into blockchain, right, well, we've defined this problem as 5 generals deciding whether to attack the fortress or retreat, right? But we could really generalize this, right? Suppose we have 5 servers that need to decide on some state that they have to agree on, right? Some records in a database. And maybe one of the servers is corrupted or hacked or there are problems. And this is really what blockchain is. This is just the heart of blockchain. You can just think of it as, computers or servers deciding on some state that needs to have agreement, even in the presence of malicious adversaries. So I guess I'll stop there and see if there are any questions so far on this.
If you've got a question, please put it in chat and I will read it out for Hart.
It doesn't look like there are any, but I just want to ask.
No. Do you suppose that all messages arrive?
That is a fantastic question. Yes, we do assume eventual delivery. Eventual delivery is actually a technical term for this. It turns out that if messages are not guaranteed to arrive, there's basically nothing we can do, right? If we have an adversary that can intercept messages, that can stop all messages between the generals, then we just have to assume that the general is corrupted or is traitorous. They may not be traitorous, but from the general's problem, right? If all of the general's messengers are traitorous, then we just sort of have to assume that the general is traitorous by default because they can't communicate in an honest manner. Does this make sense?
There's a follow-up question, Hart. Can we name semi-decentralization because the majority of them are selected for attack? And Skander, who asked about do all messages arrive, said thank you.
Awesome. So I will get into semi-decentralization actually in a few slides. Attack is, yes, it's well, how about we just push that to future slides, because I will be talking about how decentralization is a continuum in just a minute.
Awesome.
So I'll answer that question in just a sec. Great. So if we can, are we good to continue, I think?
We're good to go, Hart.
Awesome. All right. So, the decentralization problem, is natural. It's so earlier we insisted on a vote between generals. So a question you might have is, why shouldn't just one general decide, right? And there are a lot of ways to answer this question. One simple one is, well, what if the general that decides is corrupted, right? That is a very bad outcome. But in general, we're going to define decentralization as the degree to which a single entity or group of entities controls something, right? And you can measure this in a variety of different ways, whether it's the proportion of control of something by any single entity, the number of entities it takes to completely control a system, or even more complicated metrics. So for those of you that are familiar with the Nakamoto coefficient, that might be that is another way to measure decentralization. You can sort of think of this as an absolute dictatorship is totally centralized, a representative democracy is moderately decentralized, and a direct democracy is totally decentralized, at least in theory. So what is a distributed ledger? So we're going to define a blockchain specifically as an append-only system of record or a transaction log. Now, a distributed ledger is a distributed database with decentralized trust. We'll say that most popular blockchains are also distributed ledgers, and most popular distributed ledgers are also blockchains. And in this framework, we can think of popular blockchain systems in an abstract way, right? You can think of Bitcoin as sort of a distributed database for money with, I'll put it in quotes, fully, because the full decentralization is only in theory rather than practice. But you can think of it as a distributed database for money with fully decentralized trust. You can think of Ethereum as a distributed database for sort of, I'll call it programs with fully decentralized trust, because smart contracts are really just code, right? And Hyperledger Fabric, you can think of as a distributed database for programs with what I'll call partially decentralized trust. And this goes back to the question earlier about semi-decentralization. So today we're going to talk about distributed ledgers rather than blockchains, although our discussion will certainly apply to blockchains that are also distributed ledgers. So for some applications, the immutability guarantees of blockchains can be great, but it's not always the case, right? In many applications, we do want the ability to erase data. So again, the core property we're looking at today is decentralized trust. And I want to emphasize that you've all probably have seen a lot of stuff in Web3, but sort of how databases are the backbone of how, technology runs in Web2. Distributed ledgers are sort of the database version of Web3. And again, this is really just blockchain, right? If we go back to our analogy of the generals and the servers, you can think of a blockchain as sort of lots of decisions in sequence, right? The generals had to decide attack, retreat, retreat, attack. And, you can just think of all of this data as forming a distributed database. So the next thing to talk about is what is decentralized trust, right? If we're thinking of a database as a store of records, who gets to decide what records belong in the database, right? If we have one person or entity deciding, there's centralization. And if many different entities decide, we get decentralization, right? So going back to this semi-decentralization point, we really want to think of decentralized trust as a continuum, right? And the consensus algorithm is really the most impactful choice, although there are others, right? So if we sort of look at blockchains or distributed ledgers, right? We can think of things that are the most decentralized, at least in theory, as public cryptocurrencies, right? With proof of work or proof of stake consensus. As we move more towards centralization, we have distributed ledgers with Byzantine fault tolerant consensus, which I described earlier in the Byzantine generals problem. Then we have distributed ledgers with what's called crash fault tolerant consensus, which is where servers can crash, or in the generals analogy, the generals can not respond, but they're not allowed to send different people different messages. And then finally, we have, sort of centralized ledgers and, traditional databases. So this is really a continuum. Today, people sort of define this in almost a binary way, where we have permissioned versus permissionless ledgers and public versus private ledgers that indicate who can write and read to a blockchain. But I do want to still emphasize that there is a continuum, even if people do use these terms today and these terms are popular. So, if you think about where sort of distributed ledgers fit, here's an example of where, a number of different ledgers go. You can think about why there really aren't any private and permissionless ledgers. It's sort of, something you can write to but not read to is not very useful. So why do we want decentralized trust? Sort of why do we care about all this in the first place? Well, suppose we have an issue or an instance where several entities need to agree on some data, but no entity trusts any other single entity to be the source of truth. Or what if we need to make a store of information redundant in the case of compromise or an attack by a hacker? It might be the case that an entity that is the best official source of truth for some data doesn't want to or cannot be responsible for the upkeep of the data. Or maybe we have a case where people responsible for maintaining a data set are dynamic and change quickly. And the fundamental statement is that, the question, do I need a distributed ledger, is really just, do I need a database with decentralized trust? And sort of, if you remember anything today, this is the single most important point, right? Whenever you think about blockchains or whether you want to use a blockchain, you want to consider, sort of what's being stored in the database, really, even if it's programs. And why is having one centralized entity maintain this information, a bad idea or generally infeasible? And this will make it really easy for you in the future, if you think this way, to distinguish cases where distributed ledger use is sort of just hype rather than necessary. So at this point, I will, pause for questions.
And if you have a question, please put it in the chat. Let's give it 1 second, Hart. We'll see if anybody's got a question for you based on the last module. All right. I think we have one question. What do you think about transparency? This is from Regina. What do you think about transparency in relation to needing a decentralized database?
Yeah, transparency is a great reason to use blockchain. In some cases, transparency requires immutability, so it does actually require blockchain. But showing that a number of different people or parties agree on some state is really important for transparency. And I'm not going to talk about it today, but there's this idea of state proofs on a blockchain, if you're familiar with this. And it allows you to prove the state of a blockchain. And this is also really, another tool that really allows you to prove transparency.
Hey, Hart, we have two more questions before you jump. Divya asked, can you elaborate on storage capacity in relation to blockchain?
Absolutely. So, blockchains are obviously distributed databases, right? And without sort of more advanced technology like sharding, and even with sharding, it is required that people replicate data on blockchain, right? Yeah, that's right. Thanks, Sean. So, there is some storage redundancy by design, but what we generally find is that people don't store large amounts of data on blockchain. They don't need to. Rather, they store a hash of the data on the blockchain or some other commitment to the data that allows people to prove that the data was around and sort of was in existence at this time. And then you get pretty much all of the benefits of blockchain for storing and keeping track of that data, even though it's not specifically stored on the blockchain. So storage costs are something to consider. And in general, you for privacy purposes as well, which we'll talk about in a minute too, you want to store as little as you can on the blockchain.
Hey, Hart, there's another question from Brandon with regards to the ledgers. Are the blocks in the chain only created once proof of work has been completed? How does this process work in terms of the speed of the transactions?
So in a proof of work chain, yes, the blocks are only created once sort of a block is mined. This is why proof of work typically has slow transaction acceptance speed. However, most of the distributed ledgers I'm talking about today are not actually proof of work based. Thankfully, I think most of the blockchain community is moving away from proof of work. Obviously we still have Bitcoin, but where most of the business applications are happening, it's not on proof of work based blockchains.
And Sharon just asked, and we'll take this question and move on to the next section. We have ledger layer decentralization, ordering service layer decentralization, peer node layer decentralization. So just like app layer security, network layer security, we can define different decentralization layers, well, in this case, in Hyperledger Fabric, correct?
Yes, I have a whole slide on this coming up, actually. This is
okay.
So, but yes, I will explicitly point out later that you're sort of only as decentralized as your most centralized point. So that's a great point. And I guess I've got the chat up now. Does the crash fault tolerant consensus is another term, the raft itself. So raft is an example of a crash fault tolerant consensus algorithm. So there are many. Crash fault tolerance is a broad property of consensus algorithms, and raft is one such consensus algorithm that meets that property. So awesome. I guess I should probably move on to the next section then.
You're good to go, Hart.
So next, one thing we can talk about is why not, sort of always distributed ledgers, right? Why shouldn't we always use a blockchain or distributed ledger? Why don't we totally get rid of databases? And decentralization is a fantastic tool, but there are always drawbacks to using powerful tools, right? And if we use distributed ledgers, there are often issues that need to be addressed. And two of the more common that we will cover today are privacy and confidentiality and performance. These are challenging. We do address them in Hyperledger, and there are a number of different ways to address them. So one thing that a lot of people sort of like to say about privacy is that we anonymize all users, right? This seems very good in theory, right? So I will ask people, what is this? Can anyone tell me what this is? What do you think this is? Anyone in chat?
Orders made by customers on a certain date, says Regina. Credit card charges from Lorenzo.
Yes, Lorenzo, you are right. This is actually my credit card bill from a period of time in 2018. It's anonymized, right? My name isn't on it, but it turns out it leaks a lot of information about me, right? If you sort of go through this, right, I'm buying like stuff at vending machines in San Jose. Well, you could probably assume that in March of 2018 that I was working somewhere in the South Bay in San Jose, somewhere in the San Francisco area, right? You'd see me eat at a restaurant in Sunnyvale, right? Well, I'm probably like working near there or living near there or something, right? I'm eating at a corporate catering in Sunnyvale, right? Well, I definitely worked at Sunnyvale, right? You've already, figured that out. And then why am I buying groceries and gas in Redwood City, right? Well, you probably guess, I bet he lives near there, right? I have a payment to the Stanford gym. That probably lets you figure out that there's some connection between me and Stanford, and then, I'm going to a gastropub in Redwood City, right? And you see Ubers around there, so I probably did have a cocktail right at the gastropub. So just from these few days in 2018, right? You probably learned a pretty good amount about me. And this might not totally de-anonymize me, but if you had my transactions over the course of an entire month, you could probably pinpoint me individually, right? So it turns out that being anonymous really didn't buy me a lot in this situation. And this is even problematic in the permissionless setting, right? We have a lot of cryptocurrencies that incorporate privacy and anonymity techniques, but the guarantees are not always explicit. And there have been sort of attacks, not really on the cryptography of these systems, but sort of the privacy guarantees that are present there. So another sort of pitfall that people make is people say that well, everything is encrypted or hashed, right? There's no data given in the clear, right? This is a common paradigm people use on blockchain. So how many people have seen the movie Wall Street? I don't know. You all might be much younger, and maybe you haven't seen this movie. I think it's a classic movie. For those of you that haven't seen the movie, there's this famous scene between Bud Fox, played by Charlie Sheen, and Gordon Gekko, about where Bud Fox finds out where a plane is going, and uses that to sort of infer what business deal is being made, right? So Bud Fox and Gordon Gekko, in this case, figure out that this executive Lawrence is flying to Erie, Pennsylvania. They know he talked to accountants, and then they determine that he's buying this particular steel company, right? And this is what's called sort of side channel information. And this kind of information is available everywhere on blockchains, right? Even if you don't see what's inside a transaction, the existence of a transaction might be enough for someone to figure out a lot of information or break your privacy and confidentiality in some sort of unpredictable way. Um, so, as an example of this, right? Even if we have sort of, fully zero knowledge transactions, the mere fact that transactions exist in certain patterns could break privacy or confidentiality. So here, you can see, well, I've made hypothetical complicated financial deals and sort of indicated them by flows, right? So even if I can't sort of see what's in the arrow, just sort of, the weight and the timing and the type of transaction flows might let me figure out, exactly which kind of complicated financial deal is going on. And so, this is another way in which obviously privacy could be violated. You know, finally, I want to say, lots of people, take an approach where they just try to apply cryptography to a problem. And, what cryptography you use is really not equal to what security you get, right? So when we think about privacy guarantees, right, we don't want to say like my users are anonymized. We want something like, it's hard to distinguish participants in a transaction from random, right? Or for data security, we don't want to think about something like everything is encrypted or hashed. We want to think about something like, it's hard to learn any information about, any transaction on the blockchain. And so if you're thinking about privacy or really any secure system in general, I'd encourage you to start by writing down the security properties you need, and then pick the tools you need to achieve the desired security properties. Defining security is hard. It's, really hard, and I encourage people to ask for help. And weaker guarantees are okay too. And here on the right, I always list this as something where someone wrote a paper, or two people wrote an excellent paper on a situation where I defined a security property poorly. So it happens, and it's hard. So I guess, should we pause? Okay, we don't have any questions, it looks like. So if we've defined security, right, the next step is we sort of need to build a system that meets the definitions of security, right? And this is sort of, build a system and prove that it meets security, right? And this is challenging. Security proofs are hard, but they're important to get right. We have a lot of resources to help, and I would encourage you to, look at our cryptography and join the Hyperledger community. And so, we've sort of seen, I guess I should pause here before I go into solutions. Does anyone have any questions at this point?
Yeah, let's give everyone a second or two.
Gone for a
If you do have a
while.
question, put it into the chat, please. Any questions about what we've said on privacy so far? Lorenzo asked, everyone talks all day about Ethereum versus, I'm assuming Bitcoin. We're interested in enterprise tech for students. Is Hyperledger the only private chain? How does it compare to permission chains like Hedera and Ripple?
So Hyperledger is not technically a private chain, right? Hyperledger is a foundation. We have, software for, I'll call it 4.5 private chains that you can run yourself at this point, right? Fabric, Besu, uh, Iroha, Sawtooth, and I'll call Indy sort of a half since it's not a Turing complete chain, or it's not. Yes. Um, so there are many different software platforms for private chains, and there are even more uh, private chains running. There are many instances of Hyperledger Fabric, for instance. And how does this compare to chains like Hedera and Ripple? So I had a slide on this earlier, but Hedera and Ripple are public but permissioned, right? So that means anyone can read to the chain, but a few entities control the consensus process. Now, most people run Fabric in private permission chain, in private permissioned mode, which it means that regular folks can't really can't read from the chain. I will also say Hedera and Ripple are actual chains, where Hyperledger just has software for chains, if that makes sense. So Fabric is a software platform, and people run many different Fabric chains, where there is sort of one iconic Hedera chain. Did that answer your question, Lorenzo?
Yeah, if you think about Hyperledger, we're part of the Linux Foundation, which also hosts Linux and Kubernetes and other amazing projects. Hyperledger hosts the software projects that make up Fabric and Sawtooth, etc., and those communities that contribute to them. Hyperledger doesn't run a network. Hyperledger doesn't have its own network. And because this is open source, anybody can take one of these projects for whatever use case they have and run with it, whether that's using Fabric to track conflict diamonds or using Hyperledger Indy for an identity use case. The Linux Foundation, the Hyperledger Foundation are here to support the communities that build these projects. I've got a question from Stan. How do you see this affecting something like Venmo's social payment feed? Very exposed payment data for the consumer the last time I looked. And what implications for fintech players or traditional ones deploying or offering this kind of privacy through these improved features?
These are great questions. I love particularly the Venmo social payment feed because I know someone who caught their boyfriend cheating on them because the woman they were cheating with made some Venmo payments that had suggestive names. So I think that's like a really funny. Well, it's unfortunate for them, but as an external participant, it was a funny way to get caught. There are huge implications for fintech players, and we talk to a lot of fintech companies, and they're all very interested in this technology, and many of them have large cryptographic research teams working on this. Like Visa, for instance, has a huge cryptographic research team. My sort of view on traditional finance companies is that, in today's day and age, every finance company is going to have, a big tech component. And, every traditional finance company is really going to have to become a fintech company in order to survive. And if you're a finance company and you don't embrace technology like blockchain, like machine learning, you're just going to get outcompeted and you're not going to exist. So that's my sort of view on this. Are there recent developments in Fabric that could impact privacy? Yes, there's literally the slide I'm on right now. I'm going to go over one of them briefly. Is there any blockchain platform that does not involve work with cryptocurrency or any other token? Yes, Hyperledger Fabric, absolutely. And all of our projects can be run in modes that do not require tokens. Even Besu, which is an Ethereum execution client, can be run in a way that doesn't require tokens.
Hart, we got two more questions before we jump to the next session. Is Hyperledger company planning to use AI to further protect data privacy?
No, usually AI is viewed as a threat to privacy rather than something that can help privacy. You know, AI researchers may beg to differ, but usually it's a hindrance rather than a helper to privacy.
And the last question before we jump, private data through private channels will help privacy. Why will it impact performance?
Uh, so great question, but you know, private channels and private data typically help performance because it means that less data has to be sent and communicated and agreed on the blockchain. So yes, typically sending less data improves performance.
Perfect. Back to it, Hart.
Awesome. So yeah, so about Fabric. By default, everyone can see all transactions on a ledger. This makes privacy hard, but we have several solutions on Hyperledger aimed at preserving privacy properties. They typically lower performance. So, you know, sending less data is an exception, but you know, one thing you can do is only post hashes of sensitive data rather than the data itself. And this is sort of the core idea behind data collections and transactions. Right. So, you know, as you can sort of see in the diagram, you know, this unauthorized Fabric peer sees no data in the clear because it doesn't have access to this particular private state. So another thing I want to mention that it is coming along, we have some ZKP use. We don't have a ZKP library yet in Hyperledger. And, you know, I hope a lot of you have heard of zero knowledge proofs. This, you know, we could do a whole course on zero knowledge proofs, and entire courses do exist. But I'll sort of just outline what a zero knowledge proof is here. You know, so if we have some sort of statement where a prover knows an answer and the answer can be verified mathematically, then we can construct, you know, a proof of knowledge, and the verifier can sort of check the proof without ever interacting with the prover. So, you know, I don't want to go too far into this because, you know, this is sort of a big rabbit hole, but I guess my slides got mangled a little bit here, so I apologize for that. But you know, you can sort of see the differences between private transactions, and in this case, we're using snarks, which is just a succinct, essentially zero knowledge proof. It just means it's small. So this, again, is a whole course in and of itself, but it's important technology to sort of understand how it works.
And Hart, I'm going to put in the chat a link to Stephen Karan, who's one of our maintainers on a number of identity projects at Hyperledger. He did a 40-minute session on understanding zero knowledge proofs with high school math, and I'm going to add that link in the chat. It's a YouTube video if somebody wants to watch it.
Wonderful. Awesome. So, you know, another thing I want to bring up today is something called the blockchain trilemma. This was sort of coined by Vitalik Buterin, and it refers to the fact that blockchains cannot achieve all of scalability, security, and decentralization at the same time, and sort of trade-offs have to be considered, right? So things like Bitcoin and Zcash, you know, skew more towards security and decentralization rather than scalability, whereas something like EOS sort of concedes a little bit of decentralization for more scalability. And what I do want to encourage people is to not compromise on security. I really wish this had been coined as a trade-off between scalability and decentralization rather than security, because, you should not compromise on security. And sort of going back to this like decentralization continuum, right? In general, we have sort of more decentralization implies slower performance. And I've put up sort of like very rough performance numbers here. But, I want to emphasize that there are trade-offs in distributed ledgers. The challenge when picking a distributed ledger is to pick where on the decentralization continuum your application best fits. Don't use more decentralization than you actually need. And as I alluded to earlier, there are sort of lots of trade-offs in distributed ledgers, right? We can optimize for a lot of different things. And we have to carefully choose how we build a blockchain to ensure the properties we need while still getting good performance. But the main trade-off is decentralization and performance. And as I alluded to earlier in the talk, there are many different components of decentralized trust. And this was the question that someone asked earlier, and I promised a slide. So here it is. There are many different components that you have to think about, the code layer, the architectural layer, the consensus, the governance, the application layer, sort of all of these have to be decentralized. And if any one is centralized, then really the blockchain can be controlled by one party, at least in the worst case, and is thus somewhat centralized. And you have to ask the question, why shouldn't the single party run the system in a centralized way? And in some cases, there are good reasons, right? Like if there's a government agency that's responsible for governance, but they don't have the manpower or the computational power to run the system, then it might still make sense to have a blockchain, but it's still worth considering. So yeah, that's all I have. And in about the 10 minutes we have left, I'd love to answer any remaining questions.
Scander asked, is Hyperledger Fabric running on a single node? Wait, I'm sorry. Hyperledger Fabric running on a single node. Can Hyperledger Fabric running on a single node be called decentralized?
No. And if you're running Fabric on a single node, I would ask, why are you doing that? That would not be a good use of Hyperledger Fabric.
Lorenzo asked, do you see Hyperledger Solang dramatically changing the landscape in terms of adding Solana/Polkadot to the ecosystem? Or do you think ETH EVM will always be the center in terms of Hyperledger's integration? Common consensus is that layer 2 will solve the ETH scaling problems.
That's a great question. If I had the ability to confidently pick winners in the blockchain space, I would be sitting off in my mega mansion somewhere with all the blockchain investment money I've made. But, in practice, we are seeing a lot of, I guess, convergence on the EVM, really the EVM more than ETH itself. And I think that's just because there are a lot of benefits to some sort of standardization across executions. Do I think that layer 2 will solve ETH scaling problems? Layer 2 will be useful. I think it depends on how broadly you define layer 2s. I like to think of a layer 2 as like a much bigger abstraction, right? Is a private network that occasionally does cross-chain transactions or atomic swaps with a layer 1. Is that a layer 2? I sort of think so. And then then in this case, yeah, I think everything is going to be interconnected with everything else in the space, right? That's what we see today. Everyone has a database that has to coordinate and keep track with other databases. As we replace databases with blockchains, we shouldn't expect to see anything different. So, I expect to see a large proliferation of systems that communicate with each other, and that's one way to think about layer twos.
And Lorenzo made an observation. EVM seems to be making a lot of headway with ARB OP.
Well,
Go ahead, Art.
Yeah, it's broader than that too, right? I think you brought up Hedera earlier, and Hedera uses an EVM. So, there are a lot of other systems that use EVMs as well.
Cool. Sheeran asks, do we have examples of real-world use cases in healthcare where data privacy concerns were successfully addressed using Hyperledger Fabric? How can we discuss HLF security and privacy features with a healthcare provider where all requires complicated terms?
That's a great question. I don't know what the best case study we have in healthcare is. Maybe Sean, do you know do we have like
I'm gonna go see while we're chatting. So while we're talking, I'm gonna try to look it up.
Healthcare is a great application. There are a number of different ways you can use blockchain to track and manage healthcare data. I think there are some extremely exciting opportunities in this space as well. I think blockchain can be used as the backbone for federated machine learning in a healthcare application, which I think is also really exciting. So, a big one that's, I guess, not explicitly healthcare, but very, very close, is the OpenIDL network, which is for managing insurance data. And Sean can talk a lot more extensively about that than I can. I think a lot of the same concerns apply there.
Yes. So in the case of OpenIDL, just to really quickly touch on it, it's an open insurance data link. It's a consortia of insurance companies and regulators working together to find ways to be more efficient in how they exchange and use data in the industry via blockchain. Just to step back for a second on the topic of healthcare, we do have a healthcare SIG, healthcare special interest group. You can find their conversations on our Discord, which I've shared the link before. I'll share the link again in a second. But the healthcare SIG is pretty active. One of the challenges that you have in open source is that no one needs to give permission to use this software. So I will see if I can find, while we're chatting here, a healthcare use case or case study. But the reality is there are lots of folks using Fabric that we have no idea about. And we're always excited when we find out someone is using another one of the Hyperledger products, and we try to find out more about that. Getting back to the questions, someone mentioned Copperwire. We mentioned use cases. Sharon, how can we did.
Yeah, so I've got the questions pulled up now. So how can we discuss, security and privacy features with the healthcare provider? Like, this is a hard thing to do, right? Talking about, talking to someone who, probably is an expert about security, security and privacy is hard. So, this is a difficult thing. And, we always try to bring a lot of these folks up to speed as best we can. So, this is a hard problem. And, this is a sort of big societal problem, I would say, that lots of people don't understand, about privacy and security. So I unfortunately don't have a good answer for you there as a challenge. Are there scalability concepts like Cadenas Chainweb? So I'm not familiar with Cadenas Chainweb. I'm not entirely sure what graph theoretic concepts they're using. So unfortunately, I can't really answer that question for you.
Serena Vossen asked, can you give a brief idea reference to use enterprise certificate authorities? Is there any connection to Fabric CA apart from CertGen? Can we just use our certs in the file share and not bring up Fabric CA containers?
So this is a specific Fabric question. there are going to be some tricky implementation details in doing this, and I would specifically ask in the Fabric Discord how to best do this. I know you can use alternatives to Fabric CA, but I haven't done this personally in a little bit, and I would encourage you to ask the Discord channel for more details on this.
And I shared the Discord link in the chat a second ago.
Awesome. Yeah. If you really want to be fancy, you would use decentralized identifiers. But that's a whole nother step. And Sharon, I would, as Sean suggested, I would definitely suggest reaching out to our healthcare special interest group because they have the experience in talking to all of these people.
Awesome. Scander asks, what do you think about Tezos achieving 1 million transactions per second?
I mean, I don't know. It sort of is what it is. Transactions per second are all about, decentralization and the different kinds of transactions you're processing. Obviously, some transactions are much simpler to process than others.
Srinivasan says, we plan to store only data hash on the blockchain. Does this meet GDPR requirements as we don't send, I'm assuming you meant PII data, Srinivasan? So yeah.
So I'm not a lawyer, so please do not take my advice as legally binding, about GDPR. My understanding, though, is if you hash data in a way that is information theoretically secure. So basically, if you take what you want to hash, you append, 256 bits of randomness to it, and then hash it, and store that on the blockchain, that would meet GDPR requirements. As the hash is information theoretically hiding. It's perfectly hiding.
Yeah. I mean, in the case of the indie community in the early days, the concept was you don't put any personal data on chain. It's all pointers and proofs. The joke I used to make is there may come a day in the future where it's illegal to be a New York Yankees fan, and I don't want that on an immutable blockchain living forever. So, but that's a different part of the Hyperledger community. AM asks, are channels and PDCs the only option for data and transaction privacy? How can we obtain private transactions on the same channel?
So channels and PDCs are not the only options. They're one of the options sort of in the public repo, but we see people use lots of different techniques for privacy. If you're just using the channel approach, then you can't obtain private transactions on the same channel because all transactions on a particular channel are visible to everyone on that channel. So you would need some other technique if you wanted to obtain private transactions on the same channel.
It is the top of the hour. Does anyone have another question for Hart before we close this Morgan State seminar? All right, everybody. I am going to share one more time the list of links here in chat. I would like to thank Tanisha, the FinTech Center at Morgan State, and Hart for hosting us and putting on such a great event. And we really appreciate all the knowledge you were sharing, Hart. This was live streamed on YouTube. This is going to be on the Hyperledger YouTube. I'm also going to get a copy to the FinTech Center in case they want to put it on one of their platforms. And the deck that Hart shared, along with the recording, is on the Hyperledger Wiki, which is listed above. And thank you again, everybody, for joining us. And Hart, thank you. This was great. Tanisha, do you have anything to say before we go?
Thank you again. It was a wonderful presentation.
Awesome. Have a great day, everybody.
Thank you all for your time.